Hello children, today in this lecture we will discuss property, periodic property third, electron affinity, and this property in short represented as EA. According to definition which is given here, it is the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. Okay children, so in ionization potential, amount of energy are required, and electron affinity is amount of energy released. Okay, so amount of energy required when to remove an electron, and here when an atom in the gaseous state accepts an electron. Okay children, so you can differentiate in this way in these two properties, ionization potential and electron affinity. Here X, an atom, neutral condition, and when it will gain an electron, it will be converted in the form of unicharged anion, single negative charge anion, and plus energy will be evolved. So this energy which is released here will be electron affinity of the related atom or element. Okay children, so this is here. Now for detail we are moving page number 11 of your book, page number 11, and here electron affinity property is given in detail. So page number 11, periodic tens in the properties, electron affinity. Electron affinity, the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. Okay, so here atom, electron is given to the atom, negative ion is formed, energy liberated, and this energy will be first electron affinity, as we have discussed already in the case of electron potential also, ionization potential. So when first electron is taken out, first ionization potential, and same way when first electron is given to any neutral atom, the energy released will be known as first electron affinity. And then after this, when an electron is given to any negatively charged unit, then the energy liberated will be known as second electron affinity. Okay children, so on the basis of number of electron which is given to the atom, electron affinity can be of first electron affinity, second electron affinity, and third electron affinity. So maximum 3 electrons can be given to an atom. Okay children, unit of electron affinity, it is also electron volt, in short represented as EV. Okay, and because this energy is released amount of energy, so this EV is written with minus sign. Okay, minus sign, negative sign, which represent release of energy. Next heading, factors which affect the electron affinity, and the first is atomic size. As far as atomic size increases, electron affinity decreases. Okay children, एटम का साइज बढ़ता जाएगा, इलेक्ट्रॉन एफिनिटी जो है वो रिलेटेड एटम की डिक्रीज होती जाएगी. रीजन, इलेक्ट्रॉन एफिनिटी इज द टेंडेंसी ऑफ एन एटम टू एक्सेप्ट इलेक्ट्रॉन्स. A small atom takes up electrons more easily than a large atom. Okay, so since nucleus has greater attraction on the electrons, so it means smaller the atoms, higher will be its smaller the atom, higher will be its electron affinity, and larger the radius or larger the size of the atom, lesser will be its electron affinity. The second is nuclear charge. As nuclear charge increases, electron affinity also increases. Reason: nuclear charge increases, similarly increases the tendency of the atom to accept electrons. So nuclear charge increases means increase in central positive charge, which is in the form of nucleus. So when nuclear charge will increase, the force of attraction for electrons will also increase, and that is why electron affinity will increase. Next is trends in electron affinity across a period from left to right. So from left to right, as you can see here, electron affinity increases from lithium to fluorine, and for neon, which is a noble gas, it is 0, because due to the stable configuration, they are not having any urge for electron gain. Okay children, so all the noble gases are having electron affinity as 0. Atomic radii, when we move from left to right, atomic radii decreases, okay, and that is why electron affinity increases. Second point, nuclear charge increases when we move from left to right in period, and due to this also electron affinity increases. So these two factors, different factors, are acting or you can say are responsible for the increase in electron affinity, okay, from left to right in period. Then neon has electron affinity 0, since inert gases with stable electronic configuration find it difficult to accept electrons. Okay, so noble gases are already stable with 8 electron or duplet condition, so that is why they not want to gain further more electron, and this next new electron can disturb their stability. That is why they don't want to accept electrons. Inert gases do not form ions, since their outermost shell is completely filled. They need not accept or donate any electrons and are already stable. They have no urge to destabilize themselves through gain or loss of electrons, and hence do not form ions. Okay children, then overall conclusion for the periods: electron affinity increases across the period from left to right. Now then trends in electron affinity down a group. So when we move from up to down in a group, electron affinity decreases. Okay, electron affinity decreases. So in group from up to down, atomic radii increases, and due to increase in atomic radii, electron affinity decreases. Okay, and the second point, nuclear charge increases from up to down in group, but on the basis of increase in nuclear charge, electron affinity should increase, but overall electron affinity decreases from up to down in the group. Why? Because increase in atomic radii dominates over increase in nuclear charge, as we have seen in the case of ionization potential. Okay children, so due to this, electron affinity also decreases from up to down in the group. Okay, so with the help of this discussion, you will be able to understand that the trend of both electron affinity and ionization potential are the same in different periods and groups of the periodic table, and these two properties in period from left to right increases, and in group up to down decreases. Okay children, Thank you.